Okay. Right. So, to prove the theorem, let's reconstruct our thing here. So always step number one, P1 and P2, O1 and O2. And then, like I said, in geometry, you always must give statement and a reason for everything you do, remember? Statement and reason. So now, whatever you do, you have to communicate, I've done this and my reason was this. You don't do anything or assume anything without communicating with the person who's making your script. So just by joining the line PO, you must communicate that what I've done there, I have joined PO and extended. You see? So I've joined PO and have extended it. The reason was that is a construction because you made a construction.
Joined. Wait, what? What is the statement?
You joined PO and you extended it. So you joined PO and extend. That's what we did.
Oh, I see,
We
I
joined
see.
PO because we extended it a bit from after joining it because we had to go a bit far to create our angles O1 and O2.
In my textbook, it doesn't give like a reason per se. It just say
Yeah,
like joined CO and produced.
yes. It doesn't matter how they say it, but I'm just,
Okay.
remember, it's not a universal rule, but for everything you do, you must give a reason for it. But even if you can say join PO and produced, it can be seen that you constructed it yourself. So I'm just doing it formally the way not personally the way I feel, but the way it should be explained. Remember, we are just communicating and we are not memorizing how it's done in the textbook. We are just doing it our our own type of way, of which, like I say, you can memorize the very same way that it's done in your textbook. As long as you can be able to write that with your eyes closed, you would get the 6 marks if you are proving this theorem. But imagine it if you are doing it out of understanding. Sometimes, who am I to can argue with a book, bruh? At the end of the day, we are just, remember, even in trigonometry, when we are proving something to be equal to the something, if you are proving the left hand side to be equal to the right hand side, a lot of students may approach it differently. But the goal is one thing. It's just to prove if the left
Mm.
hand side is the right hand side. So using whatever conventions you can use, someone can use whatever they use. Actually, 5 students can use different approaches to get to the same path. Even books may explain this theorem differently
Mm.
based on which book I use. Yes. But following the rules is just following the rules. We can't run away from that. So even if there's no reason, even if they say joined PO and produced, the reason is they constructed it themselves anyway, if they were to say a reason for it, because it was not there. But that's how we should put it formally. Where is the PO? Where is the joint PO? And why is it extended? Where is it coming from? And then me saying the reason is construction, it's also a way of saying it's coming from here. So some of the statements we can argue them day and night, but at the end of the day, we are saying the same thing differently. So far,
Yeah.
so far before which lines do you see that are equal on that circle, including from our constructed line now?
Like as in everything, like angles
Yes,
and stuff.
looking at the entire structure, forget about the angles, just the sides only. The length,
Um,
the length of
I'd say ne, QOP is like congruent or like yeah, to ORP. You know, they're in the same size, same thingy.
don't don't go that side, don't go that side because you're saying QOP,
Yes.
QOP and POR.
POR. Yes, yes.
Okay, they are congruent. Mara, don't go to congruency. Like, don't include something that is
I
not
think
there.
it's because I'm used to like the proving with congruency, so but we'll see.
And we don't want to be used to any one thing.
Okay.
We can't settle to be used to anything. We wanna know how to do things, whatever different we have. Yes, we could do it even in congruency in a way. But for here, probably in your book, it's proven by congruency, né?
I think so. Yeah. They do say, oh no.
Okay,
I think in my book they prove it like using what is that? The triangles that we did yesterday.
okay. The reason why I'm not like, look, um
I
a
think.
good mathematician, a good mathematician is one whom, when you are able to look at all different possibilities you can use, not just, hence I say let's avoid the spirit of getting used to this type of thing only, because how do I say this in a good way? We don't have that safe space, like with the unfortunately with the system of the education the way it's designed, we don't really have a safe space to be comfortable about something. And the moment you are comfortable, they bring you new thing or make it more harder, such that that comfortability that's the reason why subjects looks more challenging, is because we had been comfortable and then they made it a bit discomfortable. Nyan. So human species, we don't like being discomfortable. Whenever we're discomfortable, like we'll do anything to make things easier for us. But unfortunately, that's what we are being tested on in subjects like mathematics and physics. So we are tested on patience. We are tested on being able to adjust to things every now and then. We are tested on having different methods to solve one problem. We are different. We are actually just to think out of the box. So there's no room for comfortable. We can't treat uh, a mathematics subject like life science. With life science, if we say photosynthesis is that, it is like that. There's no way we can wake up one day, the energy from the sun can convert into anything else. But unfortunately here, there's no facts, bruh. The only facts you have, they are based on statements and reason, but anything can be done differently. So just the open end of it. So Mara, without stressing about which book use what, let's use our own analogy to try solve this. What the
Yeah, I'm
question I
trying to
was asking,
understand
I never
using
wanted to
both.
ask basic. Yes, we're gonna get to that part. Angry, one step at a time. Works on, works off,
Yeah.
and then we get to the other one. You finish eating the pap and the gravy first before you eat the meat. But look, man, one day you'll understand. It's just that being a student is nice. At the same time, it's a stressing for and for sure. You're like, hey, the man is not getting to point. But you know how pastors. I'm not even like pastors. At least I'm trying to explain what it is. Not like like, remember, we're not writing tomorrow. We're not writing on Friday. We have enough time to can go the path. So let's finish this one first, and then when we are done, Let's see if we can use the congruence one. And then when we are done, you would at least know both.
Oh, yes, yes.
If we had that fear, yeah, just for the sake of tomorrow, we have to make sure by 8 o'clock, you know this. Let's stick to the, that's when. But now we are
Yes.
free. Time is
I'm trying to
moving on.
understand all the theorems so I can practice them like a
Yes,
lot before I write.
hear you very well. But look, it can happen over a second, right? These are the steps that we are taking for you to get to that part. You see, we are doing something. I understand very well what you want, and we are doing exactly what you want, and we are taking steps to get to what you want. But it's just the paths that we take. So sometimes we may do things that you may feel not comfortable with. And besides, not even about comfortability. After you know it, you may have your light bulb moment. Who knows? It's not even proving this theorem. It's not even that complicated. It's one of the easiest one. And as long as you got unfortunately, the construction will come like that for all the books where you have to construct P and then it has to exceed Onyana and extend those angles because you want to talk about those angles at the end of the day. Like at the end of the day, the theorem is about O1, O2, as well as P1 and P2. The rest, they're just creating our path to get there. But look at this. Look at this. Looking at your triangle, I will start and say, this is how you answer it exactly, because you are proving in triangle QOP. Now, I'm looking at one triangle at a time.
Thanks, my love.
In triangle QOP, which is this triangle. Now, from that triangle, what I observe from there is that O1 is equals to angle Q
Wait.
angle Q plus P1. I will wait until you
So
digest it. This is
triangle.
P1.
Okay, you said this is
Triangle QOP, the one in
QOP.
purple dots.
Okay. Q1 is equal to
O1, O1. Remember the center is
O.
O, this one.
O1 is equal to Q plus P. Would this be like isosceles triangle basically?
That's the question that I was asking first when I said, which sides do you think are equal? I was expecting you to pick up the radiuses. Yes, it is. But for now, I'm looking at the exterior angle. That's the reason why I say O1
Where's
is
the
Q.
exterior angle?
O1 is the exterior angle. I'm gonna have extended the line here to create O1
Oh,
here. So
okay.
from that because I've created it from there. So
Okay. So
O1, whatever I'm doing, I want to involve O1 and O2 as well as P1 and P2 because they are the main event that I need to prove in this theorem in order for me to conclude this conclusion.
yes.
So I'm following that. So hence I say O1 is Q1 plus angle P1. So since you say QOP is an isosceles triangle, wouldn't it be fair if I was to say to you angle Q is equals to angle P1?
Angle Q is equal to P1. Q P1. Oh, isosceles triangle.
We're still coping, ne?
I'm trying to understand before I copy, you know. So
I'm patient with the understanding part.
no, I'm trying to understand the reasons for these two. The ones that we wrote.
So this one, it was external angle of a triangle.
Okay. And then the other one?
You can say angles that are opposite radii. You remember that we call radii radius that are equal, right? You can,
Oh,
even
yes.
if you can say isosceles triangle, you would not be wrong. You can just write iso. You would not be wrong because you know what you are saying. Like they don't understand. Or you can say opposite angles of radii, like opposite angles of opposite
Radius.
angles of radius that are, because there is an isosceles triangle anyway. So with that information, it manipulates you to can say, then you can say O1 can be equals to double P1 since it's equals to Q. Because if Q is equals to P1, if you substitute P here, P1 here, you have P1 plus P1, which will be 2P1 because Q1 is equals to P1.
Wait, what? So O1 is equal to 2P.
2P1, yes, because Q1 and P1 are equal. So
Oh,
it's just
okay, okay, okay.
P1 plus P1.
Isn't this similar to like the parallel one, except we're dealing with radius?
I'm not sure which parallel one you're talking about.
The parallel theorem where you have to first construct a line and then prove the triangles.
Okay, it could be similar with any other theorem that you've proved in the past where you have to construct. Mara, the goal, the reason why other people feel like they memorize it, they just take it as it is and they copy it, but there's no need to memorize anything. Here, what we are doing is every now and then, whenever you are proving a theorem, regardless whether it would be a case where you have parallel lines or you have a case where you have whatever scenario it may be where you have to construct something, or it could be even what's this? I remember in analytical geometry you had to prove that angle where you would say this side is
Oh, the
half of this.
triangle.
Whatever construction you make, at the end of the day, they make you feel like it's similar to something, but it's just because now you are having the light bulb moment because you're starting to see what's going on.
Oh, I was also talking about let me show you. Like that. Okay. It's like, and then you prove the sides.
Yeah. Yeah,
Yeah.
well, yeah, it could be similar at some point when you are doing that. You're right. Everything looks similar. Every like it could be Mara. For this one, we are just trying to manipulate O1, O2, P1, and P2 to make up making sense together. So now, with O1 being 2P1, we are happy with this part. And then we can go to the other triangle.
Okay.
Because our goal is to end up making, let me just make a space there to show that that is actually O. Then I can join it just below. I can join it just below here. All right. So now I will change and say and you have to say that because now you are saying I'm talking about this triangle. It's a mark for saying that in triangle ROP now. Again, O2.
Wait, what would Q equal to P1 be? Like the reason.
Say that again.
What would the reason for um let me for this one be?
Agree we prove that Q is equals to P1. So if we're to take this, where there's Q, we put P1, we would have P1 plus P1. Because we proved here that P1 is equals to Q. So where there's Q, we can put P1 because they are equal.
So please repeat.
Look, O1 has been equals to Q P1 because of the exterior angle of a triangle. And then because of the isosceles triangle, angle Q and P1 are equal because the radiuses are equal. Now, because of Q, because of that, it means you can put P1 where there's Q because P1 and Q are equal.
Wait, what? P1 and Q. P1 and Q are equal. Oh, opposite sides. Is that fine? If I say opposite
Because of
sides.
that, the opposite sides of radi, you must say it until the end because if you say opposite
Okay.
side, the opposite what? So opposite sides of radi, meaning that radi is radiuses that are equal. We know that.
Oh, so these ones are connected. These ones are connected. It's the same thing.
Yes, it's the same
The
thing.
green and the red. Okay.
Yes, it's no. It's not the same thing. It's not the same thing. I'm just stating different thing that Q1 and P1 are equal because of the radius. And then because of that, then think of it as if I said O1 is equals to, as much as O1 is equals to Q plus P1. Now, where there's Q, I put P1 now because it's equals to, because Q is equals to P anyway, hence it ends up being equals to 2P1. I just
Wait,
probably
what?
maybe did
Actually.
step by step. Look,
So,
do you agree that P and Q are equal?
mm,
If you agree that P and Q are equal, it means where there's Q, you can put P1 in a space of Q. We call it substitution.
yo, I'm so confused. I'm understanding it at the same time I'm not.
Okay, let me wait for you to digest it and you'll tell me where's the problem.
I think the problem starts by the 2P. I get opposite sides already, but then when you did this, the explanation, kinda, it was. I mean, okay, wait, I do get it. I never mind, I do get it.
Some of the things, after I created the equation of O1 being equals to Q plus P, now I have an equation. That's my equation 1. And then I have another equation that says Q is equals to P1, which is because of the radii. And then I used both the equations simultaneously to substitute Q where there's P1 to get O1 is equals to 2P1. I don't know if I'm confusing you even worse. Should I try a different explanation?
Maybe try a different explanation and I might be wrong.
So if you agree that Q1 and P1 are equal, you just substitute where there's Q, you put P1 since they are equal. When we say things are equal, we say they are the same. So where there's Q, you can put P1. So on that formula of
Where
O
is
being
Q?
P1, we remove Q and put
Oh,
P1.
oh,
Yes.
oh, okay. Q is equal to P1 because opposite sides of radii. And then O. Oh, so O is like O1 is the okay. O1 is exterior angle. Okay, I see. My O1, I think is because I placed it inside,
Oh
but we're
yeah,
looking at the outside. Oh,
Yeah,
yes. I see where I went wrong.
the reason why we remember, the reason why we constructed it like that is because the theorem value it is about that value. So the reason why we
Mm.
constructed it is because we wanted to make P1 and P2 as well as O1 and E2 involved, because that's what the main theorem that we are proving is all about. It involves the two angle. We don't care about any other thing. Whatever we do, we always bring back to the main topic, which is about O1, O2, P1, P2. So by me putting P1 where there's Q, I was getting rid of Q because I don't need Q. I need to deal with P1 and P2, but they are equal anyway, so I can put P1 where there's Q. We still
Wait,
good.
please repeat that last part.
So since my goal was to deal with P1 and P2 as well as O1 and O2, after having O1 being equals to Q plus P1, I never needed the Q. I needed to get rid of the Q because my goal is to work around P1, P2, O1, O2.
Oh,
That's the
because we're
theorem.
proving.
Yes.
Okay, now it makes sense. So
So
we don't look at the other thing. We only look at the constructed angles.
constructed angles. As much as we may
Okay.
involve the, but we always try to come back to our main center of focus, which is the two angles.
Oh, no, I get it. I get it. I get it. So,
Yeah, that the rest doesn't bother us too much. So from here, now I'm done with the other triangle based on putting it in terms of O1 and P1. I'm happy with that. It doesn't involve Q anymore. Now I go to the other side of the triangle. Now that's when I said in triangle ROP. Then in this one, I would then say O2 again. O2 is equals to angle P2 plus angle
okay.
R. Again, exterior angles of
In
the triangle.
triangle ROP, O2 is equal to P2 plus R. So, okay, so we're doing the same thing
Doing the same thing, Mara,
to
on the
both
other
sides.
side.
Okay, okay.
And then also on the other side, you can see that angle R already, it relates to P2.
Angle R. Okay. Oh, so we're trying to get rid of. Okay, see what I'm understanding there? Trying to get rid of the opposite angle, basically, and then we only look at the constructed angles of O2 and P2.
So we're trying to
Am I correct?
manipulate. Yes, you are correct. We are always trying to manipulate to go back to our main focus, which is about P2, P1, O2, O1. So for this one, again, opposite angles of radii. So now I'm just going to create space on the other side. Same struggle, statement, reason. Great. So now we are getting somewhere. From then,
Yes.
from then, would you agree if I was to say O2 now? O2 is equals to 2 angle P2 because it is equals to R, because P2 is equals to
Yes.
R.
Yes.
Great. Now, what if we had to add the two angles, both sides? So O1 plus O2 would be equals to 2P1 plus 2P2. Would you agree if we add them?
Yes. Yes.
Great.
So it's basically saying two O's to 4p, which is like basically saying p is equal to double O.
Yes. So now I'm just gonna say O1. I can't add O1 and O2 because they are different things, just O1 and O2. I can't say 2O and divide by, I can't do that. So I'm just gonna say O1 plus O2 is equals to double P1 plus P2, just taking common factor there. And then just by doing that, we have proved our thing because ROQ is O1 plus O2 and P is P1. So just by that expression, we are done. So you just say, therefore, ROQ is equals to 2P. Because P1 and P2 that's P. And O1 and O2 represents that.
Okay, yes. Are we done?
We're done. That's the proof. That's what we were just proving. Remember, our goal was just to prove this thing.
Oh, okay.
So as much as it may look like a horrible thing to go through, Joe, it's just that. And then the next time you use this theorem, it's just gonna get you 2 marks just to remember for it. So they'll give you one angle. Either they give you P. If they say P is 2, it means Q or R4. Because it's double the other one. Just yes. So when you use it next time, you just use it directly as it is. So you just say you in a complicated shape, your eyes must be able to give you some sort of a hide and seek to can find this. Should we get an example?
Yes. We can do an example together. There's also another one in my textbook that I see, but it kind of looks like the shape we did yesterday, but it's part of this theorem, which...
Yes, they just put it in a different. Please send me a picture. Let me see. But otherwise, this is how you prove this theorem. All right. I will send you. Okay, let me open another. Let me open another thingy. Another
link.
No,
Our meeting's now hour long. Question.
Now we've gone past those days of worrying about links.
Oh, okay, because I see today.
No, now we've improved. Now we are on another level of when we
Yes.
have a
Okay, I'm gonna
lesson.
send it on the group. Because that's...
Yes. It's up to
Yeah.
us to decide when to get the lesson now.
I
Like
know.
life is better.
Yes, I see.
That's why
Thanks, my love.
I'm working on an LMS. I'm working on an LMS where I would say you can log in and go get your lesson. And like I don't know how professional can we guys be in doing that, Mara. Yeah, it is. It's more or less the same. It's more or less the same. It's just that the center is now given differently. For now, I don't want us to prove this one. We can prove this one tomorrow, ne?
Okay.
I don't want us to prove
Because
this
I'm
one
trying to
tomorrow.
understand the different basics, and then I'll be fine
Yeah.
for this theorem, and then we can do the next, and we can just do
Yes.
examples after that.
Yes. In terms of the proving, it's just constructing differently, but it's more or less the same communication. Hence, I'm saying this type of a construction we can do. Now, I wanted to search for an example for this one. So we know for today, we put this one off our side. And then the other one
Okay.
would be. So let me get examples for this. Just give me a moment. The way each and every question has different theorems, I'm just getting other examples of the theorems we haven't done yet. So just give me a moment.
Oh, so we're gonna look at the other theorems as well today, or just examples of this theorem.
We're looking for example of this one specifically.
Okay.
And something which I just want to see if you can pick it up. I'm not even gonna go through questions. I'm not even gonna go through questions. I just want you to see how it applies for now.
Ah.
Looking at this shape, and then a question comes and say to you, what is the value of
The value of
angle A2?
A2. Oh, so I could construct let me write this down. So I could construct a line there, and then okay, it's gonna stop at A though. And then
Anymore. No, you don't construct anymore.
oh
You
my
don't construct.
days.
You already know the rule. You just apply it. You just say it out loud for
I
this
just
one
don't
problem.
see what other place I could like do that.
Now, let me show you.
Basic.
Remember what we're doing now. Must
Oh,
be
I
able to see.
see. I
They
see.
are
I
playing
see.
hide and seek in your eyes. These things are playing hide and seek in your eyes. So for each and every theorem, we must be able to search for that structure inside the second. We must
Okay.
rotate our eyes in all different forms. So I never really wanted to go through a deep example like that because I still have another student who's willing to do a lesson today and I don't want to do it late. So I was just saying, let's go through us seeing what has to be done, Jay. Just being able to see that theorem. So when you apply it, you don't construct anymore. You are not proving. You are just applying.
Oh,
So
okay.
then, without even hesitating, you just say
So like
A2.
for this specific theorem, we're just proving we're not calculating angles. Okay, I mean you can calculate an angle, but other than calculating O times 2. Oh, then A
Yes,
would be 50.
A would be
Ah,
50. Yeah. That's the punchline about it. So when you come now, because you have proved it and you know how it applies, you just say angle A2 is equals to 50. For your reason, that's
then
why
it
you
would
can
be
stay
O is equal to 2. Ah, something. O
O is equals
is
to
2
2
times
times
of A.
A. Yes.
Hmm, okay.
So this is the punch. So for each and every theorem, now the trick is now they just put all the theorems into 1 second and then they rotate the shapes in different forms. And in between there, they put other parallel lines, they put other shapes, they put other quadrilaterals. And then your goal is for whatever, dude, in my understanding, this is the simplest part of mathematics because the answers are there. Like the answers are in your face. We just struggle to get them because they are playing hide and seek with us. But with geometry, with circle geometry, the answers are always inside there. You just have to look around and state the rule of why did I say this? Why did I say that? Unlike algebra, where they just give you one equation and then you have to create 10 steps in order to get an answer, which those steps must come directly from your head. You see? So this is where, if we get this one right, this is where we know we collect more marks to boost because for every distinction student, this is where you collect more marks to boost for your paper one. But
Oh,
one
yes.
theorem, tomorrow we're gonna look at this one. Oh, no, we're gonna look at your one first, that construction with that shape first, and then we're gonna look at this one as well. For sure, you've seen it on your book also.
Which one?
The tan chord theorem.
10 chord theorem. I
You
think,
haven't seen this shape.
oh no. I've seen something similar, I think. What theorem
Yeah.
was this?
So tomorrow we're gonna prove that if you have this shape, this angle here is equals to this angle here.
Okay.
It's always about angle. It's most theorems are mostly about angles. Some are about sides, yes, but the ones that are about sides, they are mostly under analytical geometry. Under analytical geometry. So in circular geometry, in most cases, most angles that we're gonna work with will be proving angles inside rather than the sides, although we use the sides to get to the conclusion of the angles. And you see, it's almost 6 marks. So for every theorem that you master, you have 6 marks in your pocket for exam because you are 100% sure it's not
Mm.
going to change. Yes. It's not going to change. You prove the theorem the very same way over and over and over. So once you can prove it four times, it stays in your head. You know you already have 6 marks in your bag.
So I was thinking, like, where would the Euclidean be, like, if it was mixed with trig and like general solution and stuff like that? Where would that come in?
Uh, when it's the part where it's mixed with trig,
Yeah.
I think it would be that type of a geometry when someone is standing on a building and then the what's this, looking up a window, and then the angle of elevation is like this to the window, and then the distance from this and
Oh,
that,
we
and then
still
maybe the
do that. Yeah.
is. It's another part. It's another part also. We're still gonna. It's just different room, similar applications. But we'll get there. We can. Room was not built in a day, and you can't finish an
Yeah.
overnight. Hey, yeah, we just have to cut slide by slide, and then we get there. But otherwise, I don't mean, like, ne, the problem is in a room of um availability. The reason why I want us to do portions a day is because I don't want it to be in a space where everything is just running all over, where you feel like, I'm so behind with a lot of things. I don't want to know this, I don't know this. I feel like if we can do one portion at a time, you would be so calm because you know everything. You are just so
Meaning,
one
I
thing.
wanted to do like understand all the theorems, then apply until the time I write. And I'm writing my first paper on the 21st of May for maths.
And my favorite statement is talk is cheap because Mina, I am here. You just have to create time and then we fix that all.
Oh, yes.
Talk is cheap. We're not on your side. You're in control of what you want. Mina, on the other
Yeah.
hand, I'm here. Like, I'm just here chilling, saying, like, when do you want to do this? And then when I can just put pressure on yourself. And it's not easy. Like, putting pressure on yourself is the hardest part. But man, sometimes I don't put pressure also because I used to be a student and I know the behavior. And I don't, at least with myself, I have a way of going to look at myself the time I used to be a student. And in some scenarios, I'll be like, Maybe I'll do the same, you know, because life is happening at that instant. Like for a kid like you could be doing these equations, but you barely see like 10 years from now. Like your mind doesn't go that far. It only ends on I need to talk to my friend. I need to see my friend. Oh, did you see what happened at school? That's what life is about. It happens here, and that's
Yeah.
how it should be. We should worry about now. Let's not like that April, that test on April that you are writing, the first one on May. Just know that you will be fine if we put time onto it. And to kill that anxiety, it's just small portions at a time. So you'll be fine on that test. Don't stress about it for now. For now, maybe you can stress about at least tomorrow. Let me make sure I understand the theorem that I did for today. Let me do two more on my own where the theorem is there and see if I can understand it. And then tomorrow when we do a new one, you have covered this one and then you know you are 100% sure. Being all over, it's always going to happen and you always feel like you want to be all over. Everyone believes they work better in last minutes. Everyone believes they work better under
Yeah, no,
pressure,
I
but
saw.
no one really do it. None of us even know what we are doing. We're just improvising. No one got it right. Even the best student at school, probably they're just lucky their brain capture things better than anyone. But no one gets home and study 24/7. Even my favorite students who are Jehovah's Witnesses, like you know those ones who are Jehovah's Witnesses, where at home you are forced to read the Bible and stuff. But they get tired, like I don't want to read anymore. so, yeah,
Yeah.
man. But we'll get it right. We'll get it right. So I'll hear from you. I'll be available also tomorrow. We're just gonna see how it goes. Otherwise, this week I know a lot of students they're just relaxed. Everyone is just on some I told them, right, you can chill until Saturday or Sunday because anyway, next week we're still gonna have time to chill from home. Maybe work even earlier during the day so we can finish, so we can focus on whatever we
Yeah.
want on our day. But otherwise, enjoy the rest of your evening until we talk again. Eh?
Bye. You too.
Bye. Sure. I don't even have to cancel the meeting. You can just go out and then I can send the link to another person. That's the break now.
Okay.
That's the
Hey.
you see, now the way it is, let's say we can even schedule meetings for future days and we have the link separate about for it without having to actually wait for finishing the lesson first too. I just haven't been exploring the premium part of Zoom and I'm enjoying it, eh? So
I can tell.
yeah,
I was enjoying it as a
that's the
student. Yeah.
yeah, that's the new way of doing things. So once we put Google Classroom, we are just like a school now.
Yeah. Hey.
Okay. Tomorrow another day to try again. Cheers.
Yes, sir. Bye.
Bye. So that's it for today, guys. I'm not gonna um go live on all the lessons that I do. Just one a day. Sometimes it's gonna be physics, sometimes it may be mathematics, could be any grade. But if you want to join us for our private lessons, feel free. You can WhatsApp us on 081 465 2676. That's 081 465 2676. I think I'll put the number also on the description. Otherwise, we are Simplified RSA, the guys who make everything looks easy. Excuse me, while you're preparing for your exams, just to make sure you kill it and you pass and you don't fail. Because if you do, it is not right. And I'm saying this because this is the outro.
Simplified RSA, the guys who makes it looks easy. Your number one learning channel.